Hi, I'm Ajay. I'm a Microsoft Certified Solution Developer, and today we are going to talk about grpc and we'll see a simple application or test application with .NET Core. So let's get started. Well, what is grpc? Well, it's an open source remote procedure call system developed by Google. It is super fast and super efficient inter-process communication technology for processes or services. So it is recommended where we want to make or we want to create some kind of microservices architecture where service wants to communicate with another service. So that's where it shines. So it is not for external applications or web applications or web API kind of thing. So it's recommended when two services or two processes or two machines want to communicate with each other that can understand the binary data format instead of a human readable format like XML or JSON. Offer lots of benefits. Let's talk about them one by one. Its first and foremost benefit is its performance, because it uses HTTP2 protocol under the hood, unlike the other technologies, like SOA, WCF, and RESTful services. Because you know though we can make use of HTTP protocol in other services as well, but we need to do some kind of code changes and tweaks there. But grpc built on top of HTTP2 protocol, so it it by default uses all the benefits that HTTP2 has to offer. And we'll talk about some of them one by one. Like HTTP2 supports binary protocol, and it also supports multiplexing requests over a single connection. What does it mean? Well, earlier, when we used to make a request to a backend server using HTTP 1.1 protocol, we would need a TCP connection to send request from client to server, and for every request we would need a TCP connection. But in case of grpc or in case of HTTP2 protocol, we just need to make a single TCP connection, and through that connection we can send streams of data, multiple streams of data from client to server and server to client. This is what we call multiplexing. And there are some other benefits that we get from HTTP2 protocol. Earlier, when we would make a request from client to server, we used to send all the headers along with each and every request, right? There was no way to compress those headers or maybe reuse those headers in the subsequent request that we are making to the same domain server. So but in case of HTTP2, it is perfectly, it is possible, absolutely fine, or it can be done with HTTP2 protocols. So, and grpc uses protobuf. It's a Google defined platform neutral or language neutral definition language, wherein we say, okay, this is kind of service we want to build, or this is the kind of messages we are going to support. It's like service contracts that we used to define while creating WCF services. We'll see how we can create a protobuf contract or definition language. We'll see in some examples. Now, another benefit that we get from grpc is its simplicity, because it offers a simple yet well-defined service interfaces and schema. In case of WCF, we needed to we would have to write some kind of service contract, and then we need to implement them. But when it comes to consumer WCF services, one needs to write a whole lot of XML configuration section in order to consume a WCF services. Server also need to expose some kind of XML details for the clients. And but it is way too simple if we compare it with the WCF and other SO infrastructure services. Another benefit that we get from this are grpc is its polyglot. So what do we mean by polyglot? Well, it supports all the major programming languages and platforms. Its service definition with protocol buffer is language agnostic. So in case of grpc, we can write the definition language, we can write the contract in C sharp, we can write the backend code in C sharp or maybe Go language or maybe Python, but the client code can be written in in Java, in Python, in Ruby. So it's polyglot. We just need to write contract once, and we can use some already offered tools to generate the templates, or we to generate the client stubs, or maybe server templates, in order to implement those contracts. As we already discussed, it supports duplex streaming, like client can send message to server, server can also send messages to client, and they both can talk to each other at the same time. So this is called duplex streaming. And there are some built-in support, like some cross-cutting concerns like compressions, timeout, load balancing, service discovery, and encryptions. It is inherently supported by grpc protocol. So these are the some benefits that we can get out of it if we switch to grpc services when it comes to creating like microservices kind of architecture. And it automatically, it's a definition language which we talk about in just a moment, like protobuf, automatically enforces all the rules that we cannot enforce in case of restful services, though there are some well defined practices in order to create you know restful services. But the http protocol which restful services use does not enforce any kind of contract that we need to have some kind of have to have some kind of contract in order to make a request to the backend server, but it enforces this kind of contract by using protobuf definition language. Though we can we can get the details about a restful service using swagger or open api, but it's an afterthought, right? So it's not inherently supported. Let's see a simple application, and let me fire off Visual Studio, and we just need to open new project. In this I'm going to search rpc, and here is grpc template. We need to have .NET 3.1 version installed. I have installed Visual Studio 2019. So let's press next. I would say sample test application, grpc application. Bear with me. grpc service, we do not want to support enable or any kind of authentication. Let's create, it will create a template. Here we are. Let's understand what it has done, what this template has done for us. This is the kind of protobuf definition we were talking about. Let's go through it one by one. So well, it's a syntax, protobuf uh, have got two versions, proto 2 and proto 3. Proto 3 comes with some more features and more benefits. You can go ahead, and you can have a look into the documentation for proto 3 benefits and features that it supports. So let's go ahead. It's about what kind of protocol we want to support, and it will create a namespace for our application. And if this namespace is missing, then this package would be used. We can comment it out from here. And this is the service that we were talking about. It's similar to like defining a service contract in wcf service. Here we are saying that the service name is greater, and in this service we are offering this say hello method, in which we expect an input parameter as hello request, and which will return hello reply. And this hello request message format would be like this hello request payload will contain a name field, and this is the ordinal position, because as we already talked about that grpc serialized and deserialized data into binary format. So to support binary format, we just need to define ordinal position. If we were to define a second property like in 32, we just need to define the ordinal position. In 32, I would say address, we can do something like this. But it's the request. We just expect that user would send name in the hello request, and in the message we would send age and address as well. So this is like you know, this is an object which will contain a property name and ordinal position would be 1, and in case of reply we are sending a message in that object, and age and address properties. So this is the bare minimum requirement that we need to write a grpc service. Now we need to implement this service at the server side. So to implement this service, so when we build this application, first off let's see some properties of this file. Here is where magic happens. Like if you see build action, you can see the build action is protobuf compiler, which means whenever this file gets compiled from this protobuffer compiler, it automatically creates a class which is greeter base, which will help us to override the methods, or which will help us to create the server side stub for this service. Let's see how we can do this. Here you can see greeter base. It is automatically created, and it has also implemented say hello method, which was written here. Now if you see, okay, where this class is coming from, greeter base, if we talk about show all files, and then it's in obj folder, and you can see this is the greeter base class. So it is coming from the obj folder, and here this protobuffer compiler automatically creates this base class, and it will help us to we just need to right click it. If we write another method, let's say I'm going to write another method, say hello, mm, say bye, and we are going to use the same objects, and let's build it. This is called interface description language. What kind of method we want to expose, what kind of object we expect from the consumer, this is kind of a definition language. So after defining it, we can go to the greeter service, and when we click on it, and what does that base class do? So that base class automatically implements the written method here, but it throws not implemented exception. We just need to override if you want to provide some extra feature. If I go and show you, this is here, you can see that rpc exception say bye, and it's a virtual method, and it throws rpc exception, unimplemented exception, but we need to override it at server end. So we just need to do what we need to do here, override and say bye. We can just override this method, and we can just return like task.from result, bye. So it's the server side implementation of this grpc. Whenever any client calls this method say hello, we will be returning this hello and the requested name. So we are done with the server side implementation. We just need to write any class with the .proto extension. Here is the way to write the methods, what property they will contain, their ordinal position, and we can mark them optional, we can mark them required, we can assign some optional value like this. But for the simplicity, we are just going ahead with this simple approach. What else we can talk about here? So far so good, I guess. So let's go ahead and implement the client for the same. So to implement the client, I'm just going ahead and adding a new application and new project. Let's create a worker service. Or maybe you can create a console application. Let me create a console application, simple console application. grpc consumer. But how consumer would get to know that what kind of data types we have created on the server side, or what kind of interfaces service contracts we have. For that, it's simple. We can just copy this file from here to client side, or maybe we can keep this grid.proto file or all the proto file that we would create into a you know uh, into on a shared location, wherein this server side code can consume this file and this client side code can consume this file. But for the simplicity, I'm just copying this file from here to here, right? And if you see, the build action type for this file was server only. What kind of stuff we want to create out of this file, because this is at the server end, we can specify server only. If we are using this file from a shared location, we can say client and server. But when we as we have copied this file, just right click on it. Okay, its build action is right now it is not showing any kind of proto compiler, right? Because we need to add some assemblies, some NuGet packages. Let's add them to grpc consumer, manage NuGet packages. Let's add grpc. Let's install grpc.net client to make call to backend server. We just need to install grpc client, and then we also need to install grpc tool in order to create the client template from this proto file. We just need this grpc tool, and it is supported by Google. Then we also need one more file if we want to define some kind of data type, which is offered by google.protobuf. That's it. We installed these three dependencies. Now let's see, when we right click on this file, properties, and here is the build action. We can say, let's build this file. Proto compiler, proto buffer compiler, and we want to create a stub for client only. Okay, now first off, let's see, when we run this application, as we mentioned that it uses http2 behind the scene. So let's run the server application to see on which port it is listening for all the client requests. Let's run our application first and see. As you can see, now listening on https localhost 5001. So this server application is listening on this 500 protocol port. So now I guess we can close it. We just want to see on which port it is listening. So, and there are some other things that this template added. It added a grpc service to the service collection in the startup file, and it also added some endpoints to support grpc services. This is the second thing that we need to do if we want to create it from scratch. um, let's go ahead to the consumer application. Now we know server is listening to 5001 port. We just need to create grpc grpc channel dot for address. So as we know, we need to create a channel. It is listening on localhost 5001. Created. Now after creating the channel, we just need to create an instance of the client. So greet dot greeter client dot this greeter client needs a channel, and we can pass this channel from where this greeter namespace come from. As you can see, this is the greeter, and this is the application name, this is the class name, and where it is similar to, like, greeter base, but when we compile this class, this proto file at client, and it creates a greeter client class, as you can see, and it also resides in the obj folder. Here's the greeter client, is a greeter client class. So what does this class do, and what did that greeter base class do? So it basically abstracting away all the transport layer, or network related details, or compression related details that we talked about. We do not need to worry all these kind of things. It is automatically inherently supported behind the curtain. Under the hood, we do not need to care about the all of the things that we talked about, header compression, or maybe it is using HTTP2 protocol. So it is automatically being taken care by the grpc boilerplate code that it automatically generates. Now client dot, and we will say bye, and when we say bye, it needs a class which is like hello request. So first off, let's create an instance of hello request property, and property name is name. I would say we are devs here, and we are passing this request. So it will return some response, it will give us some response, and I would say console dot readline, and I would say console dot readline. Message from server is this response. Yes, something is going wrong here. Let's run the server first. Build application, set a startup project, and let's run it first then. Let's explore this consumer product project. Let's go to bin debug. Let's click on this consumer application directly. There you are. See, by we sent a message via devs, and this is the message received from the on the server. Greeter say bye. This is the executing endpoint, and let's run it again. As you can see, when we execute this client again, here is the request received by the server, and it again processed say by method, and here is the response that we received. Did you see how simple it was? We just created a RPC template, RPC application, in which we just define the template, what kind of method we want to expose, their names, their input types, what kind of value we want to return, and their types we defined here. We just need to keep in mind that we also need to define their ordinal position. We can make them required, optional. We can also specify default value, and if you want to return uh, enum or list, we can say okay, this is going to be a repeated value. We need to adhere some guidelines suggested by Google, because it's a Google defined platform, a neutral or language neutral definition language that we need to read about it before defining any service. But I think it's as simple as we write in case of Java or C#.net. So not a big deal. And when we just specify, it's we can specify what kind of stub classes we want to create. If we want to create for server or client, so, and if we want to create for both, we can specify it client and server, and it automatically puts all the classes in obj folder, because we do not want to make them a part of our source control, because that way we would end up committing all the files. um, the moment we change any request or any data, or maybe we want to add new methods to our service, we do not want to commit that data to the source control. So that's why it is putting into the obj folder, and we can easily override all the newly written methods. I hope you are able to understand, or you are able to see how we can create a simple application. In case of client, we just installed these three packages if you want to see. So that's it for this session. Thank you.